This video shows that it is impossible to bring back the two-dimensional theory from a one-dimensional function. This is my theory of insurance. Point B is the wealth position of being insured, and there is an indifference curve associated with this point. If a person chooses not to be insured, his present wealth increases from x1 to x2, so he moves from point B to point A. If the accident happens, his future wealth drops from y2 to y1, so he moves further to point C. Somewhere between A and C is the expected loss, and there is the expected utility of not being insured. If this expected utility is lower than the utility of being insured, or below the indifference curve, the person will choose to be insured. This two-dimensional theory can be transformed into a one-dimensional function. Again, point B is the wealth position of being insured. At point A, present wealth is increased from the saving of the premium. At point C, future wealth is lower due to the accident. So this is the expected utility of not being insured. If this expected utility is lower than the utility of B, the person will buy insurance. This requires that marginal utility is diminishing, or a convex utility function. Can you trace back from this cardinal utility function the ordinal indifference curve? This is my theory of betting. Point B is the original wealth position, and there is an indifference curve associated with this point. If a person chooses to bet, his present wealth drops from x2 to x1, so he moves from point B to point A. If he wins, his future wealth jumps from y1 to y2, so he moves further to point C. Somewhere between A and C is the expected win, or the expected utility of the bet. If this expected utility is greater than the utility of not betting, or above the indifference curve, the person will choose to bet. Again, this two-dimensional theory can be transformed into a one-dimensional function. Point B is the wealth position of not betting. At point A, wealth is lowered by the weight of money. At point C, wealth is raised by the winning money. So this is the expected utility of betting. If this expected utility is higher than the utility of the original wealth, the person will bet. This requires that a marginal utility is increasing, or a concave utility function. Can you trace back from this cardinal utility function the ordinal indifference curve, especially when the cardinal function is not convex? Can you retrieve the spilled milk?